All right, Chapter 2, Pipeline Systems. Unified Facility Criteria Operational Maintenance of the Petroleum System, UFC 34603, 21st January 2013. Chapter 2, Pipeline Systems. 2.1. On base pipelines. On base light pipelines are used at the fill of the base of the fuel storage. Withdraw the fuel from the base storage tanks. Fill trucks that transfer the fuel between the base storage, open storage tanks. Fill an aircraft hydrant operating storage tanks and dispensing system. 2.1.1 Commercial pipelines. Commercial pipelines deliver the fuel to the base fuel storages, and these pipelines are usually underground except for the tie-in connections to base pipelines. These pipelines are constructed with the government property issuing the real estate as easement. Typically, cross-country pipelines are owned and operated and maintained by the civilian agencies. When a pipeline system is under the contract of a civilian agency, civilian responsibility for maintaining the pipeline usually terminates at some point neither where the pipelines enter the base. From the point of the bulk fuel storage area, the responsibility for the maintenance is assigned by the base civil engineering. The base civil engineering is authorized to perform the emergency maintenance on the base of the commercial pipelines if necessary to protect against the environmental damage to the public property, meet the emergency wartime mission requirements of the real estate assessment agreement with the public pipeline owner takes note of this and provides suitable contract reimbursement with the government-owned leads in the cross-country pipeline system. Marine facilities are in common with the overseas and some Air Force personnel maintain these systems. 1212 Bulk fuel storage facility pipelines. Bulk petroleum fuels may be supplied to a bulk fuel storage tank by interterminal pipeline that may be dedicated to serving particular facility. May be commercial pipelines handling several types of grades and fuels or more than one user. In some cases, the pipeline will be installation pipeline where more than one type of fuel is received, unloaded in separate lines. Unloading facilities are typically provided with each for the type of the fuel. 3. Transfer pipelines. These pipelines carry the fuel from the base storage to the transfer pump houses, truck fuel stands, and the hydrant systems. Typically, these pipes are underground except for the intermediate area of the facility involved. Most of the facility has separate issues and receipt lines. However, some facilities use single line in both. 2.2. Operating on baseline petroleum system. The fuel from fuel management flight fuel management is responsible for the on-base petroleum system according to the AFI 23201 fuels management and TO 3711. The base civil engineering provides with the fuel management light with current on-base pipeline capacity in U.S. gallons. 2.3 Maintenance of on-base pipelines. Inspection of the above-ground visual inspection of leak that drips and at the same time the other maintenance tasks are prepared in these areas. Leaking in the above-ground pipelines require welding for permanent repair. API recommended practice for 1107. Pipeline maintenance of the welding procedures. Approval from the major fuel engineering base safety with the engineering and environmental engineering with the base fire department required for the beginning of the welding or hot work in connection with the repairs. 232 Inspection underground piping at the liquid fuel farm. Liquid fuel management personnel should be aware of the various underground pipelines for the make of the general visual surveillance driving the work under these areas. The pipeline should be walked for at least 1 year. For the leaks underground pipelines can be sometimes detected by fuel surfacing on the ground. Fuel runoff in the storage drain system. The fuel underground, the pits and manholes, dead vegetation on the continuous order of the fuel. In particular area, investigation of suspicious circumstances cause the particular base environmental coordination for the guidance before excavating the soil. Periodic and documented cathodic protection surveys should be accomplished in accordance with the AFI 32105-4 corrosion control. 233 Pipeline testing. Pipelines must be tested annually for leaks. The major common fuel engineering may authorize equivalent method as long as the state environmental requirements are met. Pressure testing is affected with the weather, so that it is best due to them with the spring or the fall. The fuel, the ground air temperatures are similar. Overcast the day earlier in the morning would preferably be due to lesser of the solar effects of the above ground. Maintaining all leaks test records in the LFM shop for the 5 years unless the environmental records have dictated longer. Send copies of these records to the major common fuels engineering as requested. Use the following testing approach unless the state requires a more stringent. 2331 annual pressure testing. Pressure tests on a base fuel piping system annually using the existing system pumps. Pump pressurized unloading, loading, and transfer hydrant dispensing piping system running with the appropriate pumps against the closed system until the dead pressure is reached. The closed appropriate valve to trap the pressure in the system to turn off the pumps. Some of the ball valves do not provide with the installation require differential pressure to seat, so blind flanges may be required to take the pressure gauge readings from the 15 minutes after the allowing the sufficient time for the fuel pressure to stabilize. Visually check all the above ground piping in the concrete pits. Audibly check the closed. Check for the sound of the evidence of an internal valve leak. If no visible audible leak occurred, then take the pressure gauge reading every 15 minutes for the first hour and once every half hour for the next hour. Total time for the pressure test will be 2 hours. Documented all the pressure tests by recording the following. 2331 Name of the system test, refuel header, defuel header, and lateral pipelines provided with the facility number. The date and test of the weather conditions. Record any weather change during the test period. 23313 pressure readings, and then there are 7 additional notes of these. Pressure readings starting with approximate local time and pressure, 15 minutes of approximate local time and pressure, 30 minutes of approximate local time and pressure, 45 minutes of approximate local time and pressure, 1/2 hour approximated local time and pressure, 1/2 hours approximate local time and pressure, and 2 hours approximate local time pressure. 2332 5-year hydrostatic test. Performing hydrostatic pressure tests every 5 years on all underground fuel transfer pipelines product is typically the test media for the test. The major common fuels energy set of the specific year the hand-operated hydraulic pump and equivalent would be built in reserve tank supplies with the hydrostatic pressure that takes place of the annual pressure test. The hydrostatic test may be conducted with a dual pressure temperature compensating pressure test conducted with the same pressure specified in paragraph 23322 with the major common fuels engineering approval. The test vendor must have the independent third-party review of the test. 23321 to test the pipe, the first issuates of the indicate section must be tested with the line set spectacle flanges and then the double bleed back valves with the pressure blind flanging is not required. Note the filter separators, the thermal relief valve, safety valve sight glasses may not have been removed or isolated from the blind skillet. 2322, as it was mentioned above, using hand-operated hydrostatic, performing a static pressure to the lesser than 1.5 times the system deadhead pressure or 1.89 megapascals or 275 pounds per square inch is the maximum useful to perform all tests, and pressure may be applied with a dead weight tester and suitable motor-driven pumps. 23323. Once the pressure is stabilized, record the pressure every 15 minutes every 50 minutes for the first half hour, every 30 hours for the second, every 30 minutes for the second hour, then every hour thereafter. If the end of the maximum 4-hour test, the longest test possible, is recommended, preferably overnight. No leaks are found. Further testing is not required. Use the procedures documented in 2331. If a leak is excessively pressure charged and observed, perform a flow test of pressuring the line for the hydrostatic, measuring the record of the amount of fluid required to maintain the pressure for 4 hours. If the leak is found with the contact the environmental flight, take action to repair it. Also promptly notify the command fuels and engineering and the DESC in additional funding that is required to repair the leak and detection and location. A drop in the pressure could be result in the decrease in the product temperature and absorption of the product of the air in the line. To the rule, you may not repressurize the line, extending the test period and extend the test period for at least 24 hours. 2-4 off-base pipelines. Off-base pipelines are used to transfer the petroleum products from the refineries to the air bases, terminals, and points of the distribution. They are typically owned and operated and maintained by the civil contractors, except for the government-owned and leased pipeline systems. Will be verifying the size of the construction operation. Additional factors include the operation type of the system, the terrain features, underwater above and below the ground, the railway crossing, expansion joints, and age. Pipeline receiving the facility are typically near the base of the fuel storage, and these facilities should include an insulation pit and pressure reducing valve when used in a pig receiving facility. The Department of Transportation regulates the pipelines following the Title 49 Code Federal Regulations, Part 195, Transportation of Hazardous Liquids by Pipeline. Current edition of the following subparagraphs will provide with a general description of the type of the pipelines, operational management, operational and maintenance procedures that apply for the most systems. 241 cross-country pipelines. Cross-country pipelines are often the multi-product type. The system consists of one pipeline, a series of pump and station. The pump station have the pumps, strainers, pump pressure regulators, valves, scrapers, traps, and sump tank to collect sludge debris. The number of the pump stations in construction with the system depends on the terrain condition of the distance of the fuel must be transferred. 242 off-base pipeline construction. Pipelines are typically constructed at 12.1 meters, 40 foot of long steel pipe welded together, installed above or underground, and pipe diameters verify from 101 to 101 to 355 millimeters or 4 to 14 inches, depending on the system capacity for more complete. Understanding of the design and construction of pipelines. See Military Handbook 1022A and API RP 1100-02. The steel pipelines crossing the railroad and highways, and API Standard 1104 welding pipelines and related facilities. 243. Operating with an emergency overseat all the command's Air Force personnel may be required to take over the operate and maintain cross-country pipeline. The command fuels engineering will provide with the technical oversight of the basic civil engineering responsibility for all the maintenance of pipelines acquired by the Air Force before operating with the pipeline. The commanding fuel engineering has been delegated responsibility and should consider the following. 243-1. Secure all the plans and system diagrams and information possibility to find the location functional of all components, especially valves in the system. Some installation may require a complete engineering study to secure the sufficient information of the operational maintenance. 2432, a report should be made to decide if the necessary manpower for each of the installation personnel selected should have the experience and type of the equipment that they will operate. Skilled in engineering, electricians, mechanics, and the pump operators are usually required at each of the pumping stations. 2433, inspection of all the equipment of the pipeline system to ensure the proper working condition. Failure at one pump station can cause a complete shutdown of the entire pipeline. 244, off-base pipeline system inspection. 2441, leak detection, pressure system volume checks, line patrols, leak detection apparatuses may be used to detect the leaks. 2442, pressure checks. Pressure checks off-base pipe consisting annually with the same way prescribed on the base pipe system. See paragraph 2331. Hydrostatic testing, new piping the system in accordance with the API RP 1110. Pressure testing of the liquid petroleum pipelines. Hydrostatic testing system is lesser than 1.5 of the operating pressure of 1.8.96 megapascals or 275 pounds per square inch in the gauge maximum. During the testing, can disconnect the system components with such storage tanks and equipment that were not designed with the piping testing pressure to protect them against the damage over the overpressure. 2443, volume checks. Continuous record of the kept in the volume temperature with a liquid pass with each of the pumping station. The difference in meter reading from the control cannot be accounted for by the temperature correction between the two stations. They usually indicated with leaks, but also indicate that theft or out of calibration meters, faulty temperature sensors, or human error. 2444. Line patrols. Inspections are made by the line walkers, vehicles, and light aircraft. The air patrols should be flown not less than once every 3 weeks at an elevation of less than 152 meters or 500 feet at the ground, and speeds of 104 and 128 miles per hour. The pipeline should be marked with the post signs of the 1.6 kilometers or 1 mile intervals at the bends. The pilot acts as the observer who checks of the unnatural change of the vegetation, color of the oil slicks in lakes and streams, which are evidence of leaking pipes and areas of construction work of the road sewers that could cause the possible damage of the pipeline. The overall condition of the right-of-way, the line walkers, vehicle patrols may be detailed inspection once a year in the entire pipeline, checking the general condition of the right-of-way, valves, and the remote areas support of the above-ground pipelines, any condition that may indicate a leak. 2445, leak detection apparatus. Various types of the leak detection apparatuses are used in civil contractors. Vapor electronic devices are sometimes more common type. Alright, 2446, API 570 inspections. Beside routine and pipeline inspection, periodic inspection by expert certified in standards, API 570 will be provided by the documented remaining the pipeline life and need for replacement. They must be funded by the DESC. Alright, 25, general pipeline system components. Expansion joints. Pipelines are arranged that allow the expansion from the contraction caused by the changing of the ambient temperature, where the possible accumulated expansion contraction may be the change of the direction of the pipe running offset loops and bends with the. This is not practical to use the flexible ball joint offset. Do not use the expansion devices for the packing the slipping joints, friction fits, and or non-fire resistant arrangements. Ball-type offset joints are used to accommodate the possible setting of the heavy structures such as storage tanks and piping designs cannot provide with enough flexibility. Expansion, bending loops, and offsets are designed with stress limitation of the American Society of Mechanical Engineers B31.3 process piping and the American Association of Mechanical Engineers B31.4 liquid transportation system, hydrocarbons, liquid petroleum gas, and anhydrous ammonia and alcohols. 252 manual valves. Manual valves are used in the pipeline to control the flow of the permanent isolating equipment for the maintenance and repair. The full port of the valves are installed with the pipelines to allow picking. 2522. Do not use the gate valves in the aircraft fuel system except for when the pipeline is pickable and about absolute shutoff is not required. 2523. The specific valve types location are seen in Military Handbook 1022A. 253 surge suppressors. The following liquid of the pipeline is suddenly stopped in excessively high pressure and instantly created because of the kinetic energy flow with the converted pressure energy. The resulting shock of the often leaks that damages the connected equipment. The common device designed to decrease the shock in the pipelines is a surge suppressor of the diagram bladder type. It is equipped with the top-mounted liquid-filled petroleum gauge, isolation via liquid bleed back check valve, and the drains. The surge suppressor will be close and possible with the point of the shutoff that is expected to cause the shock. Surge suppressors can be reduced in the shock pressure, but will not be intended entirely. 254 miscellaneous equipment found at the pumping station, including the control panels, gauges, firefighting equipment, water detectors, some pumps, compressed air systems, electric measuring devices. These components verify with the type of the system and consider the accessory equipment for the major components of the system. All right, 26 general pipeline system repairs. 261 general pipeline leaks. Most of the pipeline leaks caused by interior exterior corrosion. Less of the frequently caused by the leaks included cracked wheels, split seams, separation of the collars buried in flanges, thread pipe. Initial repairs can be made with the placing of the caps over the damaged area and using the sealing epoxy components or the gaskets to seal the leak. The repairs are usually temporary and modern practices as well. The leaks are API RP 1107. The LFM should be make sure that the schematics are anointed to show that the major breaks and leaks have occurred in the pipeline. 262. Pits and small leaks. Pits in the exterior of the pipeline are caused by the corrosion that is discovered before the leaks are developed. Repair the arc welding by arc welding. Welding a circular patch over the hole may repair the small leak. All right, 263, large puncture and holes. The large holes in the pipeline create a welding safety hazard because of the spills into saturated on the ground. Clamping the steel plate of the and curvature of the pipe over the damaged area using the petroleum-resistant rubber for the seal makes the temporary line repairs, and may then be cleared and all hazardous tape plate clamped over the leak can be permanently welded to the pipe. For most welding operations, the pipe can stay in the service during the repairs. However, there's danger to the arc penetration of the pipe, thin wall, and badly corroded pipe. The system should be shut down during the repairs. All hot work must be approved with the command of the Fuel Engineering Base, Safety Base, Bioenvironmental Engineering and Base Fire Department. 27. Major repairs. Major repairs involving several sections of the pipe can be done by two methods. If the pipeline can be taken out of service, replace the damaged section with a new pipe. If the pipeline cannot be taken out of service, casing by welding over the damaged section. Casing is considered temporarily and should be used only when under extreme conditions. 28. Pipeline cleaning. Pipelines are cleaned with the line scraper throw force with the line by liquid being pumped. The intervals between cleanings vary for the size of the pipe, the type of the liquid, a drop in the flow of the rate, the continual pressure of the presence of dirt and rust in particular basket. Strainers shortened with the filter life. May indicate the need of cleaning. Batching pigs are used with separate fuels and prevent the contamination. Treating of the batching pigs is the same as the line scraper. Water slugs are not permitted to separate the batches. 281. Scraper operation. Decide the scraper best suited with the operation. Check the specification to be sure that it passes all valves and bends. Keep accurate records of the time of the scraper. Started with the quantity of the fuel pumped in the tray. The progress of the scraper. Find in the time of the interval. Receiving the station is good practice. Bypass meters while the scraper sediment in the line. The scraper should run between the minimum velocity of 3.2 kilometers per hour or 2 miles per hour. There are no shutdowns with the scraper in this line. Shutdowns will permit the scraping to settle in the front of the scraper, causing it to become stuck. This usually requires a cutting in the line to retrieve it. 282 scraping tracing. Several methods are used in the finding the scraper in the stuck lines. The knife type of the scraper must make sufficient noise to be found with the line and walkers. Brush type of the scrapers are relatively silent, requiring transmitting device to reveal their exact location. The general location can be found from time to time. Quantity of fuel pump with the stoppage occurred. Special devices include noisemaker fastened in the scraper directional antennas, radioactive material that can be found on the Geiger counter, magnetized core in the scraper that can be detected by the magnometer. Chapter 3, Mechanical Systems.